All right, we're starting off here on this first one. These problems could all look different. So it's not like there's this one problem that we have to try, because on the AP exam, these could look a lot of different ways. We're finding the limit as x approaches 5. And so yesterday we talked about it. It's direct substitution. Okay, we're doing the limit as x approaches 5, but I'm going to take, what would I do with that 5? Negative. I would plug it in. And when I plug it in, that means I'm making it negative. And so it looks like I'm finding the limit at 5, but when I plug it in there, because of where it's located, I'm really doing negative 5 because it's a negative x. So limit as x approaches negative 5. Oh, that's 4. Plus 3 times g. Hey, I'm doing the limit as x approaches 5. That one's positive. That's 5. 4 plus 15. Oh, that's 19. Oh, that's weird. Cool. But it's just a matter of understanding, what do we do? We are taking that negative and plugging it in. A lot of you gave me an answer of 13 because you were thinking, oh, it's the 2 that's negative. It's not the 2 that's negative. It's not the y value that's negative. It's the x value that's negative. That's why I'm looking there and not the other. Okay, that's more just like, hey, understanding some numbers. Let's go to number 2. Okay, here they gave us 2 things. They gave us some values and they gave us some limits. Notice that the values and the limits are not the same for each one. And then it's saying, all right, cool, what is the limit as x approaches 3? If I'm doing a limit problem down below, do I care about the values? No, get an answer and show it to me. If we're finding the limit as x approaches 3, we're finding those limits, not the values, but the limit at 3 of h. All right, cool. The limit of 3 at h, oh, that's 2, times f at 3, that limit, oh, that's 2, minus a half, g at 3, oh, that's 8. We should put them together. 2 times a half and 8, oh, that's 4. 2 minus 4, that's negative 2, times 2, negative 4. Okay. We could do an infinite amount of these problems, and every time it was asked on the AP exam, it might look slightly different. It's just understanding what we're doing. Hey, we're plugging in. We want to care about the limits and not the values. That's kind of the key. Maybe one on the AP exam, maybe none. That looked just like that, but there's some ideas. Okay, that's the first part, just kind of using our brains. We actually did that on our first homework assignment. There at the bottom, you guys did something pretty similar to that, and you did pretty well with it. All right, let's look at this next section. So now we're doing operations on functions. Okay, limits of operations of functions. So what that means here is down below we have multiple functions and we're putting them together and then finding the limit, like f plus h or f times h or f minus h, adding, subtracting, multiplying, dividing. All right, as we do these, for the most part they're not terrible, but this is an idea you need to know. Okay, I put it in a big old box and bolded it for a reason. It says, if as you find a limit of multiple functions and you get D and E, if you're finding the limit and you get D and E when you're adding, subtracting, or multiplying, you need to stop and take a second, okay? It might be D and E, but we need to examine the limit from both sides individually to make sure that that is true. So we're going to look at it, we get D and E, then we're going to look at it from both sides. If when you look at it from both sides, you get an answer, that's the limit. Okay, we'll explain what that means. Here we go. For the most part, these aren't terrible. Letter A. Find the limit as x approaches negative 2. We're going to do f plus h. So we just start with f. We're finding the limit as x approaches negative 2. That means I'm approaching negative 2 from both sides. Show me with your fingers, what number are you getting when you approach negative 2? That would be 3. Plus h as we approach negative 2. So here's h. I'm approaching it from the left and the right-hand side. What y value am I getting closer and closer to as I approach negative 2? That would be negative 1. 3 plus negative 1? 2. Boom. Done. 2. Try letter B. Get an answer and show it to me. Again, nothing super fancy. We're finding the limit at negative 2. So it's 3. F at negative 2. Oh, that's still 3. H at negative 2. Oh, that's still negative 1. 3 times negative 1, negative 9. So if we're doing limits of multiple functions and we just can find some limits, very easy. Don't overstress about it. Just do what it asks you to do. Then we get to letter C. We're finding the limit as x approaches negative 1 of f minus h. Well, here's negative 1 of f. As I approach negative 1 from the left and the right-hand side, what would that limit be? It would be D and E. And so at first glance, you're going to be like, oh, I got D and E, so the answer is D and E. Not necessarily. Okay, because if you're finding the limit of multiple functions and you get D and E, we need to check that the left and the right-hand side are not the same, okay? The problem here is they're asking you to define the limit of this new function, f minus h. We don't see that. We see f, we see h, and we can subtract them, but we don't see that function put together, all right? So I get D and E. What I'm going to do next is exactly what we did yesterday. We're going to do the limit as x approaches -1 from the left of this function. And then we're going to look at the limit as x approaches -1 from the right of that function. And we're going to do them separately and see what I get. Okay, so f from the left of -1. So we're only looking at the left-hand side. As I go from the left-hand side of -1, what is my limit from the left-hand side of -1? 2. I'm approaching a y value of 2 from the left-hand side. Minus h from the left-hand side of -1. I get 1. 2 minus 1 is 1. We looked at the limit of f from the left and h from the left, and then put that together. Then we're going to look at it from the right-hand side. Okay, f from the right-hand side of -1. Oh, that's +1. Minus, I'm going to look h from the right-hand side of -1. That's 0. What does 1 minus 0 get me? 1. Is 1 equal to 1? Yeah. Or in other words, when you look at them separately, the limit doesn't exist. But if I were to create them from the left, f minus h, and the right, f minus h, you get the same answer. Therefore, the limit exists. Makes sense on what we did. Again, that happens. If you get D and E initially, then we break it down. Letter D. Do it. Get an answer. Show it to me. We're finding the limit as x approaches 2 of f plus 2h. So f of 2, that one's good. There's a limit. But if I went h at 2, it would be D and E. As soon as one of them is D and E, it doesn't have to be both, but if one of them is D and E, yep, we need to double check it from the left and the right. So let's do that here. F plus 2h. Okay? So we're doing 2 from the left. F from the left of 2 would be -1 plus 2. H from the left of 2 would be 1. That's -1 plus 2. That would get me 1. But I need to check it on the other side. Okay? F from the right of 2 would be -1 plus 2. H from the right would be 4. -1 plus 8 would be 7. Is 1 equal to 7? No, not equal to each other. So if they're not equal, the answer is D and E. They don't have to be equal to each other. They could be, but they don't have to. We look at them separately to make sure that that's true. Questions on D? Yep, DeBoer. Say again? The first one we did was both D and E. And so that first one here at -1, I just didn't show it. But at first, F at -1 and H of -1 were D and E. So that would still work. We're doing one-handed limits, so one side is never going to be D and E. We would get one answer on one and one on the other and see if they're equal to each other. Good question. Go to the backside. Letter J. Go. We're finding the limit as x approaches 3. When I first do x approaches 3, over here, obviously, it becomes D and E for that graph of H, and it does for G as well. It doesn't matter if it's both. It could just be one. But if we get D and E, then we think, all right, hang on. I got to look at it from the left and the right. 3 from the left of H is up here at 5 times G from the left of H is down there at 1. 5 times 1 would get me 5. I'm trying to see, is that equal to, from the right side, F. I don't know why I wrote F there, sorry. H times G. H from that side is 1. G from the right side is 5. 1 times 5 is also 5. Since they're both equal to 5, guess what? My limit is 5. Those are function operations. We added, we subtracted, we multiplied functions. Okay? Now let's talk about the more fun one, which is this guy. Okay? This is called a function composition. We did this the very first day of school, function composition. We have one function inside of the other. Okay? This is what's going to challenge, do you understand what limits are? Okay? But they're good too. They're fun. Eventually. Find the limit as x approaches 0. It's a composition, so which equation do you think we're going to start with if we're doing a composition? The inside one, G. We're doing the limit as x approaches 0 of g of x. Limit as x approaches 0 of g of x. And so we're going to go to G. We're going to go to 0, and we're going to approach it from both sides, because that's what a limit is. We approach it from the left and the right. What value are we getting as we approach 0? We are getting 1. Okay? We are getting 1. And if that was the only part of this question, then I'm good. It's 1. Okay? But I'm going to ask a weird question here that's going to make more sense in a second. But I'm approaching 1. I don't care what happens at 0. I care what happens around it. What number am I getting just to the left of 0? What number am I really getting? I don't really hit 1. What number am I getting as I approach 0 from the left-hand side? 0.9999999. The x is 0.00. The y is like 0.999. Would you agree? It's just a little bit below 1. And as I approach it from the right-hand side, it's a number just a little bit bigger than 1, like 1.001. Agreed? So close that if I were to ask what's the limit, you would tell me the answer is just 1. But technically, it's a number a little bit less and a little bit bigger than 1. Well, what do you do on a graph if you want to look? That's the first part. That's G. Then I've got H of X. What would I do on the question if I want to take that 1 and plug it in, a number a little bit less than 1 and a number a little bit bigger than 1? What kind of math is that now? It's a terrible question, but that's a limit, right? A number a little bit less than 1, a little bit bigger than 1? Or in other words, I want to find the limit as x approaches 1. Both sides. I want bigger and less than 1. So then I go to my H graph. I'm going to go to 1. Here's a number a little bit less than 1. Here's a number a little bit bigger than 1. As I approach 1 from the left and the right-hand side, what number does it look like I'm getting? 3. That answer is 3. Okay, again, is it really 3? No, it's really, really close to 3, but we say the answer is 3 because that's their ending. Kind of makes sense. We're going to show you some other examples in a second, but it's just, hey, how are we approaching? We'll do another one. We'll see if it gets better on the next one. Limit as x approaches -2. G of f of x. What is the inside function? F of x. F of x. So we're going to do the limit as x approaches -2, because that's what it tells me to do, of the inside function of f of x. So I'm going to go to my f of x graph, and I'm going to go to -2. Here's -2. I'm covering up -2. I care what happens to the left and to the right because it's a regular limit question. As I approach -2 from the left and the right, what y value am I approaching? 2. And if that were the end of this question, the answer would be 2. But did I really get 2? No, what did I really get? I really got numbers a little bit bigger than 2, right? Just a little bit bigger than 2. Because here, on this side, I'm like at 2.0001, just a little bit bigger. And over here on the right side, it's numbers just a little bit bigger than 1, 2.001, okay? 2 with a plus sign. So I don't really want to look at 2. I want to look at numbers just a little bit bigger than 2. Well, how do I do in math? Look at numbers just a little bit bigger than 2? That's a limit. I'm going to find the limit as x approaches 2 with the right-hand side. Numbers just bigger than 2 of our g function. Well, I don't need the minus because I wasn't getting 2 from numbers less than 2. If I were getting numbers less than 2, that means the graph would be down here, right? It would be just a little bit below 2. That's not what's happening. It's only above the y value of 2. Good question. So now we're doing g of x, 2 from the right only. Don't care what happens at 2. It's 2 from the right because the last answer we got was only bigger than 2. What value am I getting if I'm only looking at 2 from numbers a little bit bigger than 2? 3. The answer is 3 because it changed how I looked at that second problem based off of what I got from the first answer. Okay? Or in other words, what did we get on the first answer? Like 2.001, right? And so that means I'm really doing, and if you want to think of it like this, I'm really finding g of 2.001. That's what I'm doing. It's a limit, but I'm looking at g just to the right of 2. Hey, that's going to get me 3. That's what I was trying to do there. Okay? It's a better stated as the limit. Questions on that one? It's a challenge. We'll get better at it. Try letter K. This one's a tough one. I think I've had like 4 people get this one right so far today. See if it can be you. Okay? This is a challenge. That's why I'm giving it to you. Okay? We look at this function composition. Which equation am I starting with? G of x. Limit as x approaches 1 of g of x. So limit as x approaches 1 of g of x. So when we start off in this problem, I'm just finding the limit as x approaches 1 of g. Here's g. Here's 1 right here. I'm going to cover it up. I'm going to approach it from the left and the right-hand side, because that's what a limit is. What number am I getting as I approach that value from the left and right-hand side? -1. Am I getting numbers bigger than -1 or less than -1? Neither. It's exactly -1. Not numbers bigger than or less than, but exactly -1. I am taking that value and plugging it into the other function, which in this case is f. So if I'm looking for exactly -1, is this a limit question? No, that's not how limits work. Limits are not exact. What is exact? A value. Okay, again, you can think of it like you are now taking that answer, whatever it is, and plugging it in, because that's what we're doing here. We are finding now f of -1, not a limit, not numbers less than -1, not numbers bigger than -1, but exactly -1. So that's my parachute guy. I'm parachuting down. What is f of -1? It is that closed circle. The answer is 4. It's different. You got to think your way through it. You take one answer, you use it to solve me the second one. Questions on that one? Letter K. Let's try these next two. Try L and M. Get each answer and show it to me as you get it, and I'll give you a nod, yes or no. Try both of them. Finding the limit as x approaches 0 of h of g of x. Okay, we're starting off with the inside function. The limit as x approaches 0 of g of x. Okay, g of x, here it is. I cover it up. I approach it from the left and the right-hand side. What number am I getting as I approach it from the left and the right-hand side? 0. How am I approaching 0? Numbers bigger than or less than 0? Both. Numbers a little bit bigger, a little bit less. And so it's plus and a minus. Or in other words, to do that, it's just a normal limit. I want numbers left and right-hand side, so it's just a limit as x approaches 0 of the outside function, in this case, h of x. So I go to h of x. Here's 0. I'm approaching it from the left and the right. Hey, cool. It's getting me the same number. If it were two different numbers, then the limit doesn't exist. But it's the same answer, so it gets me 1 because I'm approaching it from the left and the right. Second one, the limit as x approaches 3 f of g of x. So we're starting off with the limit as x approaches 3 of g of x. Here's g of x. Here's 3. I approach it from the left and the right-hand side. What number does it look like I'm getting closer and closer to? 2. How am I getting that 2? Is it from numbers bigger than 2 or less than 2? Less, because I don't care that it is 2. I'm coming from numbers less than, like 1.999. Okay, 2 with a little bit less. So since it's numbers a little bit less than 2, how do we look on a graph for numbers less than 2? That's a one-sided limit. The limit as x approaches 2, but only from the left-hand side of f of x. So f from the left-hand side, what number am I getting? -2. Again, if you want to, if you could treat this almost when you get that 2, but numbers a little bit less than 2, you could treat this as like f of numbers a little bit less than 2, like 1.99999. Oh, yeah, it's right there at -2. It does kind of the same thing. Questions on that one? Letter N, okay? Letter N looks like that f of absolute value of x plus 2. This one's throwing us off a little bit today. Is that a composite function? It is absolutely a composite function, okay? Because what's a composite function? You got a function on the outside and the inside. What is my inside function here? That guy. Absolute value x plus 2. That's a function, okay? The difference here is they didn't give me a cool graph. Oh, no. I can make my own, okay? You don't have to make this graph. You can think through the numbers if you'd like, or you can make a graph and make it easier on your brain. I think the graph is easier, but it's up to you. Absolute value, show me with your arms. What's absolute value going to look like? It's the V. What's that plus 2 going to do? Up 2. So 1, 2. There's my starting dot. It's a V going this way and that way. You're starting off with that inside function. You're doing the limit as x approaches 0 of the absolute value of x plus 2. Or in other words, this just means you're finding the limit of this graph at 0. And then take that answer and plug it in. Get me something and show it to me. Let's go. We're starting off limit as x approaches 0, absolute value x plus 2. So here's my graph. I'm approaching 0. So as I approach 0 from the left and the right-hand side, don't care what happens at it, what number does it look like I'm getting? 2, how am I approaching that 2? Number's just a little bit bigger. 2 with a plus sign, like 2.00001. That's what I'm getting. Okay. How do I look on a graph for numbers a little bit bigger than 2? I have one-sided limit. The limit as x approaches 2 with a plus sign of the function f of x. So I'm going to f of x. I'm doing 2 with a plus sign, or in other words, it's almost like I'm doing f of 2.00001, or numbers just to the right of 2. And what number will that get me? 4. I'm looking at this graph only from the right-hand side. It is 4. Questions on N. Letter P. Get me an answer. Go. We're finding the limit as x approaches 0 of f of k of x. So we start with that inside function, k of x. We go to k. We are looking at both sides of 0. So as I approach it from both sides of 0, what number does it look like I'm getting? 2. How am I getting to numbers bigger than 2 or less than 2? Exactly 2. So how, in math class, do we find exactly 2? Not a limit. It's a value. That is now going to be f of exactly 2. I want to go to 2 and find the number. So f at 2, I'm parachuting down. Kersplat, I am landing at 2. That's the y value when I look at that graph. Letter Q. Limit as x approaches 2 with a plus sign. 2 with a plus sign. All right, cool. We're starting with k of x. Limit as x approaches 2 with a plus sign of k of x. I'm going to k. I'm approaching 2 from the right side only. What number does it look like I'm getting closer and closer to? 2. How am I approaching 2 there? Numbers bigger than 2. 2 with a plus sign, like 2.0001. We're just a little bit above 2. And so because it's 2 from the right, numbers just bigger than 2, the way we do that in math now is we find a limit as x approaches 2 with a plus sign of the other function, h of x. Again, it's almost like you are finding h of 2.00001. We go to h. We go to the numbers to the right of 2. What am I getting? -1. Kind of makes sense. I would say out of these last ones, I do not need you to be 100%. Absolutely not. I'd like you to be at around 60%. If you're 60% correct on these, you're doing great. Okay? On the ones that we've done the first 2 days, yeah, I need you to be about 100% on those. But if you're at about 60% on this, you're doing excellent. Okay? Don't let these stress you out. If you're not good at this, you absolutely can still get an A in this class. You can absolutely get a 5 on the AP exam. Okay? But this stretches you a little bit and makes you think about things in a different way. Questions?